Hi, Craig Petrie at Bitware here. This video is an introduction to the S7t-VG6 FPGA Accelerator card, the first of its kind to feature the new Speedster 7t FPGA from Achronix. I'll be walking you through the main features and use cases for this product. We've got a lot to cover, so let's get started. For those of you who are new to Achronix, they are the only independent high-end FPGA semiconductor company that offers premium standalone FPGAs along with eFPGA IP technology. Achronix is uniquely positioned to address the needs of high-performance applications that require programmable hardware accelerators. Demand for their products is driven by the rapid expansion of high-growth markets, including AI, cloud, 5G, and ADAS. The Achronix Speedster 7t FPGA family is optimized for high-bandwidth workloads and eliminates the performance bottlenecks typically associated with some traditional FPGAs. Built on TSMC's 7nm FinFET process, Speedster 7t FPGAs feature a revolutionary new 2D network on chip, referred to as the NOC, plus an array of machine learning processors optimized for high bandwidth and AI workloads. It also boasts GDDR6 interfaces, delivering HBM2 level memory bandwidths, 400GB and compatibility with PCI Express Gen 5. All the chip peripherals are interconnected via the NOC to deliver ASIC level performance while retaining the full programmability of the FPGA fabric. To learn more about the details of the Speedster 7t chip and the associated ACE tools for programming your application, please visit the Achronix website. Okay, let's take a closer look at the accelerator card itself. The first thing to note is that this is not a traditional development kit. Dev kits are for lab use only and are unsuitable for deployment. The S7t card was designed from the outset to be an enterprise class product for both rapid proof of concept application development and cost-effective, reliable deployment. This approach is powerful because it provides customers with a quick and affordable and low-risk deployment path. As you can see, the form factor is PCI Express, specifically full height 3/4 length. The card adheres to all the mechanical and electrical PCIe 6 standards. By adhering to this form factor, the S7t card is compatible with just about every server and edge platform on the market, supporting large GPU accelerators. The default configuration is a double-width passive heatsink. However, active fan cooling and even liquid-cooled options are available upon request, along with single-width cards also. When customers purchase the S7t card, they receive a 1-year license for a comprehensive software bundle that includes the Achronix ACE Design Suite and a toolkit from Bitware. The toolkit leverages Bitware's 30 years of FPGA card and system-level experience. Specifically, it features a sophisticated board management controller, or BMC, that allows customers to monitor the health of the S7t card under application load. For example, power consumption, voltage, current, and temperature monitoring, plus various other important parameters. The toolkit is supported within the latest versions of Linux, which most of our customers use. But for some customers who have application legacy complications, or simply a preference, we also support Windows as an optional extra. There is an extensive API and PCIe driver set available, multiple application example designs demonstrating how to move data between each of the main FPGA peripherals. These are delivered with source code to help you build your application on top. Finally, there is a diagnostic self-test, which is the baseline for our technical support and warranty services. This test is part of our production test regime and is used by customers before starting their application development to ensure that the card has survived transport, handling, and installation. It is also a golden image, useful during debug, which verifies that all the features are working correctly to maximum performance. Let's now take a closer look at the headline hardware features of the S7t card. First up is a PCIe connection, which is the full 16 lanes. The card will initially support PCI Express Gen 4, however we have designed the card to be PCI Express Gen 5 compatible. The Speedster S7t FPGA is rich with an array of multi-line rate SerDes, Mark, and FEC hardened IP, supporting everything from 1 to 400 gigabits per second. We have leveraged technology from Bitware's parent company, Molex, to design in two types of network cages, QSFP56 and QSFP-DD, or double density. The QSFP56 is the 1 by 200 gigabit E port. The QSFP-DD is the 1 by 400 gigabit port. Both network ports can be broken down into multiples of 10, 25, 40, and 50 gigabit E connections through the use of interconnect product from Molex. The other headline feature of the S7t Accelerator card is the innovative memory architecture. Instead of using HBM2 integrated memories on this particular FPGA, Achronix has included GDDR6 hardened IP. The S7t card supports 8 independent banks with capacities of 16 gigabytes. This produces 4 terabits per second, or 512 gigabytes per second, of external memory bandwidth, which is in line with HBM2, but without the cost. GDDR6 memories are used extensively in GPUs and are multi-source. This architecture also allows Bitware to customize the card for volume applications. Customers who need, say, half the memory banks for their application, in that case, we can depopulate 4 of the banks in order to reduce the price and the power consumption per unit. This is a straightforward option that would require different FPGA and potentially a new PCB if we were using an FPGA with embedded HBM2 memory. The S7t card also includes a single bank of DDR4 as the buffer and cache level memory option. Okay, so those are the headline card features. However, many applications need subtle but often hugely important additional features needed for applications to run efficiently. First up are the SMA connectors on the front panel. These are clock inputs which allow customers to synchronize multiple S7t cards for timing critical applications. Without these, it is difficult to scale network-enabled applications. At the right side of the card, we have a general purpose digital I/O header. This is a relatively low-tech connector running 8 single-ended pins from the Speedster S7t FPGA through voltage buffers to convert from 1.2 volts to 3.3 volts. This header is extremely important when customers are integrating new acceleration technologies into legacy systems, which need simple digital triggers or control loops. At the rear of the card, we have a mini cool I/O connector, which serves as a multi-purpose expansion port. MCIO connectors are new to the market and are designed to support PCI Express Gen 5 line rates. There are 4 main use cases for this port on the S7t card. The first allows the FPGA to interface directly with NVMe flash storage arrays. This allows data captured through the network ports to be pre-processed, then recorded directly to the NVMe storage via a cable assembly. This is an extremely powerful use case as it allows high bandwidth, low latency access to the NVMe storage without having to go through the CPU subset. This allows the CPU to be reserved for other functions or even exchanged for a lower cost, lower power CPU, since the FPGA is able to do the storage access itself with its own NVMe controller. The other use case we see at Bitware is the need to scale FPGA applications across multiple devices. As good as PCIe is, when you try and scale via the host interface, even Gen 5, chipset, driver, and operating system issues may compromise performance and increase system-level jitter. Using the MCIO expansion port as a simple SerDes, i.e. a non-PCIe protocol, customers can interconnect Speedster S7t devices directly through a simple cable assembly that can be supplied through Molex. Customers can interconnect using whatever topology best suits their application, daisy chain, ring, or mesh. Using this technique, customers will have a low latency, high bandwidth, and most importantly of all, a deterministic interface between the FPGAs in the system. Number 3, as I/O rich as this card is, there are always some customers who just want a little bit more. In order to help cater for those customers, an adapter can be used to bring in even more network ports from the front panel to the Speedster 7T FPGA via the MCIO expansion port. The fourth use case, as was the case with the GPIO header, the MCIO expansion port is protocol agnostic. That can be used therefore to integrate into older legacy systems. For customers wishing to purchase at the server level, the S7t card is available as part of Bitware's TeraBox range. FPGA cards are delivered to customers as pre-integrated, pre-tested servers with the mechanicals and thermals already figured out, plus a comprehensive warranty covering both the server and the FPGA card. The operating system, the Bitware toolkit, the Achronix ACE design suite, they're all preloaded and ready to go. Customers just need to apply power, log in, and run the diagnostic self-test to verify that everything is good. Thanks for watching. For more information, please contact us via bitware.com.